So hi there, this is Randal Schwartz once again back with another tip or trick or technique around Dart and Flutter. Today I'm going to revisit a subject I visited many times before, which is how to get things to happen in main before the rest of your code starts up. And there's lots of ways to doing that. The things that have been a little trickier that I've been demonstrating lately is how to incorporate it with Riverpod, for example, or with other async things like, say, Firebase initialize, or getting shared prefs, getting the handles of that, things like that. So we've had a number of strategies to be able to do that, but I've come up with a sort of an interesting way of firing up Riverpod providers with full error handling and with full parallelism and really kind of a nice setup. So I'm going to go ahead and describe it by showing off the code first. Over here we can see that we've got main.dart. Nothing else really. This is the only file. We're pulling in future and timer. We're also getting log, the developer, from the developer library. And we also need math, so we're going to have math to get random. And then pretty much standard libraries here. We've got Flutter Riverpod. We're going to do an HTTP call, so we're going to get those. We're going to also use generated Riverpod providers, which is the sort of modern way and recommended way, and I kind of like that now. Also, again, just to demonstrate shared prefs, I've got that. If you had Firebase, of course, well, whatever you have, those are going to end up in here. This is a generated file. Since this is main, the generated file is main.g.dart, which is going to be where the providers from Riverpod are generated into. And in fact, let's get right into that. So we're going to have a series of providers that are all providing some sort of async value. We have them in a variety of different styles, too, just to demonstrate how this is happening. For example, your shared preferences fetching, which is this line here, shared preferences get instance. You want to do that once at the beginning of your program and make it available everywhere. It typically doesn't take very long, but it is async, so you have to end up taking care of that in your main, especially to make that work. Or you end up doing it every time, and I've seen people do that. Sorry about that. That's not the right way to go there. But anyway, do it once, and it's fine. We're going to show that as similar to, say, doing a Firebase initialization, which would be a similar operation. Then I have a normal Riverpod provider, which when generated is not keep alive. It's auto-dispose, using the old terminology. And this one's going to be a little fun because I wanted to basically have something that occasionally throws. So first I make a delay for 3 seconds. That's just to have some time before either the success or failure happens. Also to make sure that we see that we can do things that are asynchronous that take time to do. We're also watching for when this gets disposed by setting a callback on dispose. And then we decide whether we're going to shoot ourselves or not by picking the next bool randomly, which of course is true or false, right? So should throw is now either true or false. If it should throw, we throw an exception. I throw it from 3, which is the name of the providers, just so I can see that. Otherwise, I return should throw, and obviously, that's returning a bool. I'll never see the bool if the bool is true, but this is just kind of make it a complete provider. And then our third and final provider is go-getter. So it's going to be a family generated provider, which is going to take a URI, and it's going to say it's going to go fetch it, and we want it to keep alive for 15 seconds. So the easiest way to do that is to just simply create a keep alive link and then close it 15 seconds later. This will ensure that even if nobody is watching it, it will stay around for 15 seconds until the next person watches it. It does not force it to reset after 15 seconds. It just means that if nobody's watching it for 15 seconds, it goes away. So this is probably the simplest kind of keep alive that I could demonstrate with. So I put that in there. And then, of course, we actually go out and get the URI. So that comes from the HTTP library, which I imported at the top of the program. And there are our providers. So we want to warm all three of those up. And these are all generated, so they're all going to have some name like go-getter provider, 3 provider, and prefs provider. We're going to end up, we want all three of those to be warmed up by the time we're running our main code. And we want some nice animation display while we're waiting. Here's how simple the main becomes. Okay, we just simply call in async. I really don't need that to be async anymore. That's interesting. Because there's no await in here, is there? So let me just see. I'll also probably break my demo. Let me just do that. Let's see here. So we want to get rid of future as well, right? Now you get to see exactly how well I type. Good. Yeah, still happy with that. We'll save that. Okay, yeah, we do not need async in here because all the async stuff to get the warm-up is happening in a moment. We set up our provider scope, of course. We call our warm-up shim, essentially. It's going to sit between the main and the actual real app that's coming up soon. Okay, so here's warm-up. This is the fun part. So it's a consumer stateful widget. So that means it's going to have a ref available to the state function, or the state class. And it also is stateful, so of course it has a state class. So down here, we end up with a variable in our state called warmed up. Initially false, of course, because we're not warmed up yet. And yeah, always name your booleans in the positive way of what's actually true. So typically most booleans will start false if something still needs to be done. Okay, now down here in the actual build, we say we trace the warmed up value. We'll see this when it runs. We'll see that it says warmed up false or warmed up true. It'll say false for a while because it's not warmed up yet. But if it is warmed up, we return an actual app. So that's going to be the transition once it's warmed up to not go to any of the rest of this particular widget. It's going to skip right over to the real widget for the real application. However, in the meanwhile, then, when we're not warmed up yet, what we want to do is end up with a ref watch on all of the providers that need to be warmed up. Here's the list of providers that needs to be warmed up, and this particular type narrows it down to just the ones that I'm interested in. So these are providers or provider selectables, that return an async value, so that's just future providers and stream providers. And we don't care, so we see object question, we don't care the type that they're based on. We only care that they're ultimately an asynchronous provider of some kind. Now, then we just list them. Prefs provider is one of them. 3 provider is another. So the first one was the shared preferences. The second one is the one that throws sometimes. And then the third one was a family, so we give the family value here. So this whole expression still turns out to be a provider listenable, which is how we're getting away with having it being one of the elements of the list. It's also why this can't be const, because this computation here, this URI parse, can't be const. So this has to be done this way. There might eventually be a constructor for URI that you can give it constant things and come back with a constant URI, but that has not happened yet. So we still have non-const URIs. Now, this list are the 3 things we want to have running. So what we do is we take the next step here, which is that we take that list of providers, we map it through ref watch. So this will take each of the individual providers, hand that as a parameter to ref watch, and return back the watched subscription. Now, that, of course, because it's map, comes back as a iterator. So we need to then, or iterable, I should say, we need to map that to a list. So now states, if we look at it, is a list of async value of object question. So that's good. Now we have a list of the results of those 3 providers. Wow. Okay. And it's also whatever the current state is. Is it loading? Is it error? Is it data? We can now start making our states be based on that. So first we're going to handle any errors for all the, scrolled a little funny there. For all of the values for each state in states, if it is an async error, then we know we failed. So we'll log that just for now. You wouldn't want that turned on in production, but I'm doing it to be able to see what's going on. And this magic line of code here, throw with stack trace, state error, state stack trace, is essentially rethrowing the error that has been held inside the async error. So the point of this is that this warmup widget is sitting between the rest of the code and your main. And hopefully your main, if you're doing something like Crashlytics or some other analysis system of some kind, you've set that up in main ahead of this. And this will act for those failed providers just like they threw directly to that. So it sort of gets out of the way and says, here, you take the error. I really don't want it. So this is a nice little trick to learn. It took me a while to find this in the documentation to figure out how to do this. So that's really nice. Okay, so if anything blows up, the first one of those that blows up, we are going to throw. And that is not reached after that. Once we throw that error, he's gone. He's not. We're not running this code anymore. And the analyzer knows that and knows that the code right after this is unreachable. Okay, so following up on this, we then look to see if every state is async data. So when does it become async data? Well, we know it's not async error. But if any of those are still loading, then it's going to be async loading, right? So, but if all of them are async data, then nothing is loading. We are done warming up. And we will then want to set state the warmed up to be true. Now, you can't really set state during the build. It doesn't work. It needs to be done sort of as a callback. So I found, I know a lot of people do the, add post frame callback stuff, but that's just too verbose. It turns out that if you set up a future and you don't await it, then it happens after you're done building, exactly when you want it to be done. So now I can see a whole bunch of people going, oh, I could just do that instead of the add post frame callback. Yeah, you really can. It's really not that difficult. So anyway, so I'm calling after the build, I'm calling set state warmed up equals true. Now, this also means I have an unawaited future, but it's not complaining about that from the analysis, and I've got the analysis turned up pretty high. So apparently that's okay to do that. Okay, so we have an unawaited future here. Now, and also notice we still didn't have to make this method call. This method call is still synchronous, right? Because we're in a build. Build doesn't have build is always synchronous, so there's no async in here. If I wrote await here, it wouldn't work because it would say, no, you have to be in an async. Okay, now, if we make it past something is broken, and we make it past maybe everything is all done, we still want to show something happening on the screen while we're warming up. So my favorite one for this, of course, is fitted box, child, progress indicator, circular progress indicator of adaptive. Why the adaptive? Because then it looks right on the local platform. It's going to be a spinner or some sort of dots flying, whatever the particular underlying operating system wants. And that's really nice. It's a fun one to remember. They added that only maybe a couple of versions of Flutter ago. But I like using it now. So that means that the fitted box just makes sure that it fills the entire screen. So we're going to get a filled screen circular progress indicator. Now, here's what's interesting about the flow. So we initially come down and everything is in loading state. So we're going to get past the error state. It's not all async data yet. So we just come straight down to here, fitted box. Okay, so that's going to start the spinner. spinner, spinner, spinner. We're going to keep cycling through that. Now, one by one, these are going to become async data, but it's not until all of them become async data that we get down to this, and then we set state to warmed up as true. Now, because that's being done after the current build, we're still going to hit this bottom line one more time. So we continue the spinner for one more frame, and it works. Because what we want to do is get back up to the top here now, where it's warming, where it says it's warmed up. We want to go to my app without having set up any of these ref watches, right? We don't want that to be on permanently because we want to have the providers be able to define their own keep alive strategies. In one case, we've got 15 seconds. In another, it goes away immediately. We want the providers to define their own keep alive strategy, and the only way to do that is to get these ref watches out of the chain. This takes care of that. So warmed up gets set. We do one more spin. The next rebuild comes up. Now notices warmed up is true and goes immediately to the My App. That sequence works great. You'll see it as we start running the code. So now we're down into real normal code. This is nothing unusual now. We've got a consumer widget that's going to get the prefs, so we can look at prefs. It's going to get the Flutter dev, the one that I preloaded, this one up here, right? So it's going to be fetched immediately because it's already warmed up. But I also, just for grins, pulled up Google as well. So this one is actually going to be loading the first time we paint the screen. But this other one with Flutter dev is going to be already loaded. And if you watch really quickly, because it's loading Google's really fast, you'll see the slight delay there and see that it actually reloads the page as well as finally brings up Google. Now, nothing fancy down here. We've got prefs, dev, and goo all dumped out, and this is just standard scaffold stuff, so I won't bother with much of that. Okay, so over on my right here, I've got my emulator. Let's go ahead and fire this up, provided it works this time. Okay, good. Well, that's warming up. Okay, we're rebuilding this. Hopefully, it doesn't take too long to do that. I'm trying to think of anything else I left out of here. So the bottom line here is that warm up widget is going to sit in between main and the top. Oh, here we go. There's our spinner. 3 seconds of that. Boom. Oh, I guess 3 decided to blow up. So that's no good. So in fact, if we go down to the debug console here, you'll see that we did call warmed up false down here, right? So that's that. So that means we're going to go into that warmed up routine. We're trying to fetch Flutter dev. We come back to warmed up, and it's coming back there 3 more times, and that's because the fetch is going to return, the prefs are going to work, and then finally 3 apparently blows up. And so then we get this error, and we get the right stack trace and everything. That's just to show that, yes, that all works down there. Okay, now here's the tricky part about this demo. I'm going to keep restarting it until it works right. But when it works right, watch carefully in the middle of the display here to watch for first the async one to fetch Flutter dev is going to be immediately ready. But then just a moment later, the one for Google will go from loading to ready, loading to data. Let's watch. So let me go. Click. Spinning. It worked. Okay, there. Hopefully you saw that down here. Okay, I'll do it again. Hopefully you'll catch it this time if you didn't see it the previous time. Or back up the tape. Hey, this is all recorded anyway. So this is the preferences. That's up and running. And it is keep alive forever for the entire lifetime of the program. So we'll never have to worry about that timing out. But then we also had the Flutter dev one. The Flutter dev one over here was already ready, in async data. But if you caught that, watch right here when I reload this. Watch right here, and watch for this to be an async loading just for a second. So let me do this again. Spinning. Nope. Okay. 50-50 chance. Booleans. And how many falses can I get in a row? How many three? There we go. Boom. Okay, there. Did you see that right there? It changed just a second. So I hope you liked this. I think this is going to be sort of a template for whenever I need warming up in the future of providers, because it's kind of nice. I suppose I could package it, but there isn't really anything except this one warm-up method here. I mean, this one warm-up widget. So probably the only packaging I'm going to do is clean this up and put it into a GitHub repo so that you can look at all the code that I've just done here. And otherwise, that's today's trick or tip or technique in the Flutter and Dart arena. I am Randal Schwartz. Please click all the things and like all the things and tell your friends about this particular feed. And we'll see you again next time.